Here we have a long wire with a circular cross section. It has a radius r. There is a current going into the wire in this direction, but the current density is not uniform. In other words, per square centimeter, more current flows here than what flows there. And it is a linear relationship. J, which is the current density, is some constant alpha times the radius r, if this is r. So you see current density here is higher than here. Let's make an enlarged cross section. And we have therefore here the radius r. And I have here a concentric circle with radius little r, and one that is slightly larger, so that this thickness is dr. And I would like to calculate now with you what is the current going through this ring, so to speak. Well, that current di at that location r must be J at that location r times the surface area of the ring, which is 2 pi r dr. So if I want to know the total current that flows in this whole surface area, in other words, up to radius r, so I up to radius r, including this whole area, then I have to do an integral. R has to go from 0 to r, and I find 2 pi alpha times the integral from 0. Oh, let me first do the integral all the way from here to here. Yeah, so let me first do I total, which is this total value. So that would be then from 0 to r, 2 pi alpha, and then you get r squared dr. And that tells you then that this equals 2 pi divided by 3 times alpha times r cubed. And so you can write that differently if you want to. You can say that alpha therefore is 3I. This is I total now. Total current through the cross section divided by 2 pi r cubed. All right, so this is not too difficult. To get the current, the relation between the current and alpha, current going through this whole cross section. And now, as you see, I was getting a little bit ahead of myself. Now we want to know what the magnetic field is at all values of r. And so we have two domains. We have the domain whereby r is smaller than capital R. And we have a domain where it is larger than capital R. Well, I suggest that you do this one, and I will do this one. Here is the cross-section, radius r, and I'm now going to apply Ampere's law. So I have here a closed loop. Remember Ampere's law? That connects a closed loop. This is a closed loop that you must choose, equals mu0 times I through. And that I through is through a surface, which is an open surface, attached to the closed loop. And this is that closed loop. And whether it's a floppy surface, bulged or flat, doesn't matter. That's the amazing thing about this law. I will choose a flat surface, not making our lives too difficult. And so the current I that goes through this area that's why I put an r in here, that through the area up to radius little r immediately follows from what we just did, alpha r cubed, this is alpha, and this is also the same as I, the total I, r cubed divided by capital R cubed. So if we apply Ampere's law and we go around in this circle, the magnetic field by convention is in this direction. It's everywhere the same because the radius r little r doesn't change. And so we get that B at that distance r times 2 pi r equals mu 0 times the current going through that flat surface, uniquely determined, and that equals I r cubed divided by r cubed. And so out pops immediately BR. And what you see is that BR is proportional to R squared. If the current density had been the same throughout the whole surface, not linearly growing with R, but the same, then you would have found that the magnetic field inside the wire would have grown linearly. 0 at the center and growing linearly to the outer radius. Now it grows in a quadratic way, in a parabolic fashion. I think you should try to convince yourself that it's linear if the current density had been constant throughout. Now, when you are going to do your part to calculate B of R for R larger than R, there is one thing, it's really not so difficult. I really did the part I believe that is more difficult than what you have to do. But what I want you to check, that your result is exactly identical to my result when you substitute little r equals capital R. The two must be the same. So please check that. Those consistency checks are important. They don't cost very much. They give you some confidence in your results.